Yes, students. So we know that how does the current is affecting the magnetic field lines and feeling the force. And we have also seen that when the strength of the current is going to be enlarged, at what position. So now we find now the direction of the force, and that is with the help of Fleming's left hand rule. So what does this rule suggest? Okay, as we have seen that here we were having in the example that we were discussing earlier, we were having this magnet and this rod that is connected with the electricity, and that is in between the normal magnet, horseshoe magnet, north to south. So the magnetic field lines are coming through it like this. Okay, and the current that is generated in this rod is going to produce magnetic field around it. Okay, that magnetic field in certain direction now going to clash with this magnet field line. Okay, and that is going to produce the force that we know. We have already seen that. Now what is the force direction? If we want to know, so here we are having a very big help. So what is this? Here with the help of your left hand, you can just put all these fingers, like this is thumb, this is one forefinger, this is middle finger. So just put all these fingers in a perpendicular direction like I have done here. Okay, so by putting it like this, this is perpendicular to this, and this is also perpendicular to this. Okay, as you can see, this is perpendicular. Okay, and even this is perpendicular to this, and this is perpendicular to this also. So all the three of fingers of mine here are perpendicular to each other. Now you can just see here what we have represented. Here the thumb part is representing the motion, that is force, because without force you cannot generate motion. That we have seen in last class 9th. Yes, that we have read that here due to force the motion get produced. Okay, even here when we have set up this kind of example activity, what we have seen that now this rod is going to feel certain force due to the its own magnetic field and due to the external magnetic field. So here the clash of the magnetic field is there and it will feel certain force. That is okay. That is perfectly fine. So now the direction of force is going to be developed. Where is the force? So that force is going to produce in it in form of motion. This rod will automatically get moving. Okay, so that motion is helping us in certain applications that we can use in day-to-day life. As I have told you, we can use it in motors. So now students, for seeing here the thing that the forefinger of ours is showing us the magnetic field, and here the middle finger is showing the current. Okay, so as I have just drafted the in a graphical representation, and even I can draw it for you like this. You know, when we used to draw a graph in mathematics, so what we have done, x-axis, y-axis, and this is going to be z-axis. Like this, even this is going to be z-axis. Agar hum isi ko aise lateral kar de, to that is also correct. Okay, so this is z-axis. Fine students, so now as you can see here, this is y-axis, this is x-axis. This is perpendicular to this is also perpendicular to this, and this is also perpendicular to this. That is fine. So in this case, what we are going to see here, the thing that we can learn is like FBI. Okay, you know that F is the force, this one, FBI. This is FBI. FBI. So F is what? F is the force, B means magnetic field, and I means current. So whenever we know that here, in case like we can take the example here also, FBI. Okay, like this I am going to produce my fingers in this way, FBI. Okay, so this is FBI. Now see, if we have given force, we want to know the force. Let's suppose there is a magnetic field, external magnetic field. If we are taking this B as a symbol and we are taking in the Fleming's left hand rule, so this would always be the external one. not one that is produced by the current. Okay, in case of current, we can just take the current's direction. We don't have to take the direction of the magnetic field that is produced by current. Okay, now let's suppose the magnetic field lines are going to be in this direction. Okay, and current is going to be in this direction, like this, like here in outward, like इससे बोर्ड से बाहर आ रहा है on my side. ओके, लाइक दिस, ऐसे आ रहा है. सो वेयर, अगर ये ऐसे उधर से आपकी साइड से इधर की तरफ आ रहा है, अगर हम इसको 3D वर्जन में समझते हैं, सो इन दैट केस कि ये रॉड कैसा फील करेगी, जैसे लेट सपोज दिस मार्कर इज माय रॉड. ओके, तो ये वहां से इधर आ रहा है लाइक दिस, और मैग्नेटिक फील्ड लाइन इसको ऐसे क्रॉस कर रही है, तो वेयर इट विल फील फोर्स. नाउ वी कैन टेक दिस एग्जांपल एंड वी कैन गिव द आइडिया दैट इट विल फील फोर्स इन अपवर्ड डायरेक्शन लाइक दिस. Certainly, when the thing is coming towards us now, and due to this field, it will going in upward direction on a very simultaneous time. Okay, so this is what the Fleming's left hand rule is going to tell us. You just keep learn that this FBI is putting your fingers like this. So F portion is for thumb. If you are taking the F part is like this, so I am putting it like this, that the force we don't know. Let's suppose force we don't know, we can just put this 2 fingers in direction of the current and the direction of the magnetic field. So we can arrange these fingers accordingly, and according to that we can generate where the thumb represent the direction of the force automatically. Okay, so we are going to see how motor works according to this Fleming's left hand rule.